If you've spent any time studying ancient engineering, you've probably had that moment, that pause, where something simply doesn't fit the accepted narrative. For those of us who live and breathe ancient history, especially here on Era Fusion History, few subjects provoke that reaction more than the granite drill core holes of ancient Egypt. The deeper you dig, literally and metaphorically, the stranger the story becomes. We're talking about cylindrical cores extracted from solid granite, spiral drill marks etched into stone harder than modern structural concrete, and boreholes that challenge our assumptions about Bronze Age technology. These artifacts have been examined, debated, dismissed, and sensationalized. But when you strip away both mainstream complacency and fringe exaggeration, what remains is something even more fascinating. A genuine engineering mystery that deserves serious, grounded exploration. Let's break it down properly, historically, archaeologically, and mechanically. Most of the granite in question comes from Aswan, in southern Egypt, where ancient quarries supplied stone for some of the most ambitious construction projects in human history. From the massive blocks inside the Great Pyramid at Giza to colossal statues and sarcophagi, Egyptian builders clearly mastered granite, working on a monumental scale. Granite is not limestone. It's an igneous rock composed primarily of quartz and feldspar, with a Mohs hardness ranging between 6 and 7. Quartz alone sits at 7. Harder than copper and, honestly, significantly harder than bronze. Yet much of Egypt's major stonework took place during the Old Kingdom, particularly during the reign of Khufu in the 4th dynasty, around 2589 to 2566 BCE. Conventional archaeology tells us that the Egyptians used copper tools, stone pounders, abrasive sand, often quartz-based, and of course, immense labor organization to shape and drill granite. And indeed, we have abundant evidence of copper chisels, dolerite pounding stones, and tubular drill reconstructions. But the drill cores themselves, that's where the narrative gets, well, uncomfortable. When archaeologists excavated certain sites in the 19th and early 20th centuries, they discovered cylindrical stone cores extracted from granite blocks. These cores were the byproduct of tubular drilling, a technique in which a hollow tube cuts a circular groove into stone, leaving a central cylindrical core. One of the most discussed examples comes from the Great Pyramid complex itself. The 19th century engineer William Flinders Petrie carefully documented drill cores and spiral striations during his survey work in the 1880s. What he observed has fueled over a century of debate. The cores displayed spiral grooves, fine, consistent, helical lines wrapping around the cylinder. These were interpreted as feed marks from a rotating drill. But, the spacing of those spirals suggested a rate of penetration that appeared, at least to Petrie, surprisingly rapid. Here's the key point. The spiral groove pitch, the vertical distance between each turn of the spiral, seemed too wide for what we would expect from a manually driven copper drill, using sand as an abrasive. That observation has echoed across generations. Let's talk mechanics. In a tubular drill using copper and sand, the copper acts as a carrier. It doesn't cut the stone directly. The quartz sand, harder than the copper, does the actual abrasion. The drill rotates, pressure is applied, and over time, the granite is ground away. Experimental archaeology has shown that this method works. Researchers have replicated ancient drilling using copper tubes and abrasive slurry. It's slow, laborious, and requires patience, but it works. However, when modern engineers have examined the ancient core samples, they've noted something curious. Some spiral grooves appear very regular and relatively deep. Petrie calculated a feed rate, the amount the drill advanced per revolution, that seemed unusually high, possibly over 1/10 of an inch per revolution. For a hand-powered drill system operating on abrasive grinding, that's aggressive. This is where people start jumping to conclusions. Claims of lost advanced civilizations, alien intervention, or high-speed rotary drills thousands of years before their time. But as historians and serious enthusiasts, we need to stay grounded. The real question isn't, did they have futuristic machines? The real question is, are we underestimating the sophistication of their mechanical systems? Ancient Egypt was not technologically primitive. It was mechanically clever. We know they used levers, ramps, sledges, and coordinated labor forces at a scale unprecedented in the ancient world. We also know they were capable of precise alignment in monumental structures. Just look at the astronomical precision of the Great Pyramid. So, when we look at these drill cores, we have to ask, could the Egyptians have used more complex drilling rigs than the simple bow drill reconstructions we often see in textbooks? A bow drill is effective for small-scale drilling, but for granite cores several inches in diameter, a larger apparatus would have been necessary. Imagine a weighted vertical shaft drill mounted in a frame. Add downward pressure via suspended stones. Incorporate multiple operators rotating a horizontal beam. Use a steady supply of quartz sand slurry. Now you're talking about a system capable of sustained torque and consistent pressure. Such a rig would still be primitive by modern standards, but it would dramatically increase drilling efficiency. There's another factor that's, honestly, often overlooked: time and repetition. If you drill enough holes using the same rig setup, your technique just naturally improves. Toolmakers keep refining those copper tubes. Workers figure out how to really optimize that slurry consistency. Over decades or even centuries, efficiency just keeps rising. The Old Kingdom wasn't just experimenting randomly. They were building state-sponsored engineering programs. One of the most cited examples that comes up in discussions of Egyptian drilling is a specific artifact, often referred to as Core 7, reportedly discovered at Giza and examined by Petrie. The reason it attracts so much attention is because of the distinct spiral striations and the apparent uniformity of the cut. But here's what's really important. The sample's interpretation relies heavily on 19th century measurement and observation techniques. Petrie was brilliant, no doubt, but he didn't have modern materials analysis tools, digital microscopy, or three-dimensional scanning capabilities. Now let's zoom out for a second. If the drill cores were just isolated anomalies, we might be tempted to dismiss them. But they actually exist alongside another astonishing category of Egyptian stonework: the massive granite sarcophagi found in places like the Serapeum. Many of these boxes feature flat interior surfaces, right angles, and smooth finishes that seem, honestly, remarkably refined. This really suggests a developed industry of stone machining, not high-speed electric machining, obviously, but organized, repeatable, systematic stone processing. The granite drill cores of ancient Egypt don't prove impossible technology. They show us something far more profound, that ancient civilizations were capable of levels of precision and mechanical innovation that we're still working to fully understand. If you enjoyed this deep dive into one of Egypt's most fascinating engineering mysteries, make sure you subscribe to Era Fusion History, share this with your fellow history buffs, and join the conversation in the comments. History isn't finished, it's waiting for us to keep digging.